Okay, just a quick update that I'd promised when we last met. The Juno mission, which has been orbiting Jupiter since July 4th of last year. And just to remind you the way this was expected to work, here it's coming in from Earth. It does a rocket firing to get captured into orbit. And then it was supposed to do 2 of these very long orbits that take 53.5 days. And then last October, mid-October, they were going to fire the onboard propulsion system again to lower the orbit into these 14-day, what they called science orbits. So here's Jupiter right here. And in fact, what happened is in mid-October, as they were preparing for the close approach, they were testing the valves in the propulsion system, and one of the valves seemed to be a little bit sluggish. And so they backed off and said, okay, we're going to postpone the orbit, or the orbit trim maneuver until the next time that we come around. And in the interim, they discovered that there was an Earth orbiting satellite that used the same valves in its propulsion system. And one of those valves actually failed on this Earth satellite, which gives them a lot of concern. So they've been studying whether or not they really are going to do the trim maneuver. And so the last close flyby was in December. The next one is next week. And they expect sometime in February they're going to make the decision, either go ahead and change the orbit or leave it in this 53-day orbit. If they have to leave it in the expanded orbit, they still get the close passes. It just takes much longer to collect all the science. So instead of lasting a couple of years, it's going to be a much more extended, lengthy mission to collect the same data. So we should know by the next 60 minutes whether this trim maneuver is going to happen or not. So I'll update you next month. But just a couple of the cool images that have been coming back, or the data. This is an infrared view of the aurora over the south pole of Jupiter. And so it's in a polar orbit, so we see both poles, and getting lots of information on the magnetic fields and the plasma environment, the atmosphere. And this is just a view of what they call the pearl on Jupiter. This is actually a storm in the atmosphere, and this is a closer up view showing all the turbulence in the atmosphere. And then this would be familiar to anybody with a decent telescope, the Great Red Spot on Jupiter. Okay, so let's move on to one other mission that has returned a lot of fascinating data. The Cassini mission has been orbiting Saturn since 2004. That was a very eventful year. In January, we had the 2 Mars rovers. July 4th, this mission arrived. And so it's been returning data since mid-2004. And this is just a view of all the different orbits that it's gone through in that time. And pay attention to this yellow set of orbits. I'll talk about that in just a second. So all of the redirection of the orbits are caused by close flybys to the large moon Titan. So they use that as a gravity assist to help adjust their orbit. And so in December, they did this a pass by Titan, and they've adjusted the orbit to what they're calling the grand finale orbits, where they're now going over the poles of Saturn and coming very close to the outside edge of the rings. And then in late April, they're going to do another maneuver that puts them between the rings. Sorry. Oh, come on. between the rings and the cloud tops of Saturn. And I think I've got one more closer view here. So here's where they are right now. And then starting in late April, they're going to be doing this. And then in September 15th, they actually dive into the atmosphere. So that's the end of the mission on September 15th. Just a few of the really cool data sets that have come back. So this is from up near the North Pole of Saturn, looking, here's the shadow of the planet and looking out across the rings themselves. And well, I'm not sure what happened there. And this is the moon Mimas, which it's sort of a distorted view. Mimas is actually well outside the rings, but or it's actually between us and the rings. So Mimas is closer to us, and we're looking across the rings. Mimas is about 400 kilometers in diameter, so that's a neat view. But I think anybody that's seen Star Wars recently will recognize the truth of what Mimas is. It's and this was actually observed back in the Voyager days. It's got this very large impact crater with a central peak in it, but even back then, well, once Star Wars came out, it became called the Death Star moon. So the last thing I wanted to talk about on Mimas is just what these new orbits are going to do for us. So this is a look down on the rings. This is the outside, this F ring that has a little satellite on the inside and outside called shepherding moons that keep it narrow and ropey. And then you've got the main rings of Saturn. So Saturn would be over here. And you see these gaps in the rings. And each one of these gaps is related to the gravity of one of the moons. And this is the smallest gap, the Keeler gap. It's about 40 kilometers wide. And the thinking was there must be something orbiting in that gap. And it's just too small to see with the existing observations. And so here's a view taken a number of years ago. So here's the F ring. And here's the Keeler gap. And the thing to notice as you go along, this isn't a nice, smooth, edged gap. There's these little divots and waves in the gap. And once they started studying this, lo and behold, this was in 2005. There's a little tiny moon right in the middle of the gap. And you see these waves in the inner and outer edge of the gap. And so since 2005, we've really wanted to see what that moon is all about. And this is just sort of a time lapse showing that there's something in here. They don't, at this point, they couldn't see the moon, but something is definitely driving those waves. And then subsequently, they got a little bit closer. So there's the moon. It's called Daphnis. And this is a mathematical model of how they thought this worked. So you've got this small moon. Here's the gap. It sweeps all the material out of this gap. But then as it travels, as it orbits around Saturn, the material in the rings that is closer to Saturn orbits somewhat faster. This material is somewhat slower. And so the moon actually generates waves, vertical and horizontal waves, which is what we're seeing, that a regularity in the material. And so this was, I think, in 2009 when we went through the last equinox, where the sun was coming in basically edge on to the rings, and the sun actually would be up here. And you see the waves are casting shadows on the rings. Here's the moon, and there's the shadow of the moon across the rings. So that gives you an idea that the waves are actually multiple kilometers high. And I think this is a time lapse showing how the waves are following the moon. And this was taken in the last 10 days. So this is by dint of the new perpendicular orbit. So we're looking down on the ring, and there's Daphnis. It's about 8 kilometers long. It's very flattened. They think that all this smooth stuff is probably the ring material that's been swept up that gets drugged down onto the moon itself. There's several ridges on it, and you can see the waves that it's making on both sides. This is, you see this sort of fuzziness here. It's where material is probably being drugged into the gap, and then there's little clumps in the material, and it breaks up into finer and finer stuff, and then eventually falls back into either getting swept up or getting back into the ring. And so that's the type of stuff they're going to be spending a lot of time doing over the remainder of the mission, is looking at the details of the ring dynamics, which they haven't been able to do because they haven't had the right geometry to really do it. And I'll just leave you with this, one of the beautiful views that Cassini has returned of the planet. And just to remind you, and we'll certainly be keeping you updated on this, unfortunately the end of mission itself is at about 5:30 a.m. Mountain Time. So it all depends on what kind of coverage NASA is going to provide, whether we just record it and play it back later in the day, or whether we actually do a live event. That's still under discussion, so we'll keep you posted on that.